the change in the fixation. And that allows for the eye to be able to focus the light rays back on the retina and for us to continue having clear, sharp images of the world. These processes you don't have to think about, right? All you have to do is decide where you want to look. Or something grabs your attention. It could be some distant object that grabs your attention or some close object, and all you do is you look at it and you know where the object is partially based on some of this information that goes from the lens and the extraocular muscles to the brain. So we call this class of signals oculomotor signals, or cues, because they emerge from the motor component of visual processing. Precisely the muscles that control eye position and the convexity or the power of the lens inside each eye. Then there's a whole class of visual cues that could be further classified in terms of whether they're static or dynamic. In other words, are they moving visual cues or stationary visual cues? The moving visual cues are a couple, but the most important one is the one I'm talking about here, which is motion parallax, and it's simply an unfolding of the laws of optics in motion. Objects that end up being close to us as we're moving through the environment, let's say you're driving a car or you're in a train and somebody else is driving you, but you end up moving in the world. Objects that are closer to you move in the opposite direction but at a faster speed. Objects that are farther away from you move still maybe in the opposite direction depending on the distance, but at a much slower speed. So again, without thinking, without having to spend any effort whatsoever, your mind is uptaking all of this information and translating the speed, the apparent speed of these objects into an index of where they are in space. The ones that are close to us move faster, the ones that are far away from us move slower. This phenomenon bugged me for as long as I can remember when I was a boy, going on road trips with my parents. Because I kept seeing the mountain following me everywhere I went. But the electricity poles, the trees, the close by objects, passing by very quickly. It only took me about 30 years to figure it out. I'm happy to share that with you right now. So this is a very rudimentary depiction of this, very static depiction of it. And I also have a little video, it's a silent video by a Montreal artist, which is why it's written Parallax Motion as opposed to motion parallax. But here, let me back up, and you see this person moving through the world, and you see what I mean by this sort of gradient of speeds as a function of where things are in space. So these little bits of what they look like grass or something, they move quickly, the buildings move slowly, and this is probably Montreal with the cross on top, moves much more slowly, or even maybe stationary in the background, depending again on your distance. So that's that. So there are movement cues emerging from the image that falls on the retina. Okay? So now we're talking about the content that the eye is seeing or capturing, and what can be extracted from it to drive the rest of the process. Then there are a whole bunch of other visual cues that are all static. So they're often called pictorial cues or static visual cues, and they all refer to basically a set of signals that you can pick up from images like this. Again, without thinking, you look at this image, and there are several things you extract from it immediately. This guy is closer to you than this guy, right? The mountains are farther away than this bush or this cactus. And the road doesn't get narrower, but it just stretches into the distance, even though visually it looks like it's getting narrow, and it may come to a fusion point somewhere down the line. So these are things that are part and parcel with our experience of the world. Presumably, we learned these things very early on during our postnatal development, just by mere exposure, by implicit learning. Some of the theories behind it suggest these things, and some of these kinds of capacities may even be built into the system. So, an infant born 5 minutes ago may be able to extract some depth information from the world, as seen in monkeys, as seen in human infants, and other infant creatures. So what are some of these cues? One of them pertains to where information lies along this dimension. We call this relative height. So if you take this two-dimensional flat image and you say, well, this is, let's say this is the x-axis down here. This is, where's my pointer? This is the y-axis. So this could be the width and this is the height of the image. Relative height could indicate something about where objects are in a very predictable manner. So those components of the image that are lower end up being closer. That's a rule of thumb. Generally speaking, this area of any image ends up being closer to you than this area, right? And it holds true in this example. The mountains are further back. They're really probably the farthest thing away, except for maybe the sky or the clouds up there. But generally speaking, whatever's on the ground has this kind of tendency. The parts that are lower in the image are closer, the parts that are higher are farther away. Then there is the signal that emerges from objects partially covering each other. This happens all the time. You look into the world. It's rare that you have access to the full structural information of an object unless you move around or move some objects away from your field of view. So even right now, if I go behind this table, even though I hope you still see me as a whole person, you actually don't have the perception or the visual input of a whole person. Yet you're able to figure out that the reason you don't see parts of me is because something is in front of me, right? So that in and of itself becomes a very potent cue. We're constantly bombarded with this kind of information, and from, again, maybe very early days of development, or maybe even from an evolutionary history, we've learned how to deal with this lack of information, partial access to information. Those things that are seen more wholly are in front of things that are seen partially. That's basically another rule of thumb. So that applies to this scenario here, for example. You have this cactus covering some of the bush. So what's in front of what? The cactus is in front of the bush. As simple as that. But how much do you really think about these things? None, right? It just happens spontaneously, effortlessly, as a result of you just opening your eyes and there's something for you to see. Nothing more, nothing less, right? So that's part of the beauty of this whole process, and partly why it's been so successful to tap into it as a form of maybe technological advancement and so on. But the other thing we're not mindful of, but we often use very readily, is access to what we call relative size. So objects of known size, familiar objects, like a motorcycle, end up being perceived to have a fixed size, no matter how small or large their image is on the retina.